capacitor. Here you consider two plates. You can take this is plate P and next plate you can take it is Q. This is Q. The distance between the two plates it is taken as D. The first plate P is charged positively. By induction, the second plate Q is charged negatively. So next we have to mark the direction of electric field. So first we have to mark the direction of electric field due to this positive plate. Positive plate means the direction of electric field is always represented as outward direction. So E1, here also E1, here also E1. And next step we have to mark the direction of electric field due to the negatively charged one. So due to this plate, the electric field is inward direction. Let us take it is E2. We know the electric field intensity due to a plane sheet. The equation is E is equal to sigma by 2 epsilon 0. So here we have to first calculate the electric field intensity in the outer region of the first plate. The first plate here it is P. The resultant electric field E is equal to E1 minus E2 because both are opposite direction. Right, sigma by 2 epsilon 0 minus sigma by 2 epsilon 0. So the resultant electric field intensity in the outer region of the first plate is 0. Next we have to calculate the electric field intensity in the outer region of the second plate. Second plate also the direction of electric field is opposite. So that we can write E is equal to E1 minus E2. Here also sigma by 2 epsilon 0 minus sigma by 2 epsilon 0 which is always equal to 0. Next we have to calculate the electric field intensity between the plates. So if we consider between the plates, both the electric field are pointing in the same direction. So that we can write E is equal to E1 plus E2. E1 is sigma by 2 epsilon 0 plus sigma by 2 epsilon 0. Here if we take LCM 2 epsilon 0 we will get sigma plus sigma. That is 2 sigma by 2 epsilon 0. Here 2 and 2 cancel. We get electric field E is equal to sigma by epsilon 0. So here our aim is we have to calculate the capacitance. So to calculate the capacitance, we know the equation C is equal to Q by V. Next we have to calculate the potential difference between the plates. So potential difference V is equal to E into D. Electric field into the distance between the two plates. Substitute the value E, you will get sigma by epsilon 0 into D. This is the potential. So here it is a plate so that the charge Q can be written as Q is equal to sigma into A. Sigma will represent the surface charge density, A represent the area of the plates. Then we can use the relation C is equal to Q by V. Here Q is sigma into A and V is sigma D by epsilon 0. The sigma and sigma cancel. We get capacitance C is equal to epsilon 0 A by D. And here you just consider, if a dielectric constant K is inserted between the plates, then we can write the capacitance as C is equal to K into epsilon 0 A by D. So here the capacitance depends on the dielectric constant, it depends on the area of cross section, and also it depends on the distance between the two plates. If dielectric is inserted between the plates, the capacitance value can be increases.
If you found this video helpful, please like, share and subscribe to the channel. See you next class.